right, hi everybody, good evening and welcome to this live session on Microsoft Excel and nested functions and formula arrays, or arrays within formulas, arrays that are returned by formulas, and arrays that are taken as an argument within Excel functions. Okay, let's get started. We are going to generate some sample data. What do we have? And we are going to use the data that's being generated to hopefully it works. It seems a bit buggy. Let's see what we can have. Says okay, so we are going to review how to create nested formulas in Excel. So how can we use multiple functions to create one long main formulas in Excel and obtain one result from those different embedded functions inside Excel. So I'm sorry, my application seems to be a bit buggy. It doesn't show the data inside. Here when I write something, it doesn't show me. Let me see that we have the automatic. Okay, let me close and restart and see. Okay, hope this time it will work. It doesn't show me the text, which is very disturbing. Alright, just fixing a few technical issues with my computer that doesn't show Excel correctly. Bear with me a minute. Okay, just trying to close the application again and restarting it, and eventually getting an alternative ready as well. Okay, I think I might just close just close edge. Okay. Okay. Okay, just a few minutes trying to get something up and running. I've had a few issues um, with Excel on my computer. Hope we can find a fix very quickly. All right, it seems we are good with the virtual machine. Okay, here we go. Okay, all right. So now we have our Excel working. We can start doing something. Let's create some dummy data that we can use to, I didn't especially want to have it here. So, okay, just generating some dummy data that we can use to create the different function that we are going to, that will give us an idea of how to use array formulas, and also we're creating nested functions and use different type of arrays and what they are exactly. Okay, so we can do another one here with books. Okay, so actually the first data set is quite interesting because it contains the cost and then the quantity, and we have the total, which is the multiplication of the cost times the quantity, right? So we can look inside the total and see that it is the quantity times the cost. So with that, okay, so with that, we can obtain the overall total of our data set, right, of the total cost time the quantity. So if we right click within our table, so we have a table structure in Excel, we can right click within our table, and from the contextual menu we have table, and we can display the totals row, which is display just below. We can expand a little bit our column, and we obtain the sum of all the totals for each row. So that's one way of obtaining the total, but we could eventually do another way. So we could also use, if I go just beside here, we are going to create a simple sum function. Sum, we are using the sum function, and we are going to multiply two arrays together. So that will be the first example of how to use arrays and what are arrays. So I can select the cost, I separate it by a comma. Sorry, no, I actually need to multiply them. So I'm going to multiply that first array by the quantity. Okay, and here I will obtain, so the list of cost, or the column cost from the table 1 will be multiplied by the table 1 quantity, and the result will be summed up. And with that, if I click enter, I obtain exactly the same result. What we have inside table cost is an array. So we can expand that, actually. We can expand that a bit. And with the table 1 cost selected, if we hit F9 on our keyboard, we are going to reveal what's behind that name, which is an array. So an array is expressed as a list of values placed between curly brackets. And each value is separated in this case by a semicolon, because the data is organized within a column. So each value is placed into an individual row within that column. So we have those values separated by a semicolon, and we have all those values. So if I scroll back up to the beginning of our list, well, it doesn't, actually it doesn't take them in the same, no, we have it here, the cost, sorry, I got confused. 53.45 is the first one, 53.45. Then we have 70.36, which is the second one just after the semicolon. So if we do the same for the table quantity and hit F9, we will have another array representing the quantity column of the table 1. So those two arrays, each item of those two arrays are going to be multiplied together. So the first value is going to be multiplied by the first value of the second array. So actually we can also, if I escape that, okay, I go back to the beginning, I can also select both arrays with the multiplication sign, and I can also hit F9, and I will obtain the multiplication of each value within an array. So they are also separated by a semicolon, representing so a new row for each of those values within that column array. And again, if we scroll back up to our table, we are going to see that the first value of the total column represents 2031.10, which is the result that we have obtained within our array for the first value, representing the multiplication of the first two values of each array's cost and quantity, which currently returns an array also. Okay, which we can see within the wish I could have increased this, but I cannot increase it so much. We can see, let me try and see if I can use up, not what I wanted here. If we have zoom it, yeah, that's the tool I wanted to have. Okay, so up. All right, now we go. Here we go. Okay, so actually here we can see, okay, that an array start with a curly bracket, and when an array is represented as a column, each row or each value is separated by a semicolon, which we have here. Okay, so each value is separated by a semicolon, and an array starts with the curly bracket and ends with the curly bracket as well. Okay, so now the sum function is going to sum up all those values within that array and return one value only. So if I select my entire function with the closing bracket, then we obtain the result that we want. We hit F9 and we are going to see the resulting value from the sum of that array. So escape to return to what we have, and which is exactly the same as the totals that we have in the totals row. So in fact, we have the first quantity times the first cost, then the second quantity times the second quantity. Each are here separated, and in that function we have done it in once. Okay, so now we could also use the sum product, we would obtain the same. So equal sum product. The sum product takes in an array as the first argument and an array as any other argument. So it takes in arrays. Okay, so we are going to type in the name of our table, open the square bracket, and we can select the column that we want to use. So the cost, okay, close the square bracket, and the second argument, the second array that we want to use in our sum product function will be, so table 1 square bracket to start listing all the different columns that are from that table. So we will use the quantity, close the square bracket, and we can close our bracket, the normal bracket. Here the function is constructed slightly differently from the sum function, because the sum product will sum the product of all arrays that are entered as arguments within that function. So we don't need to specify the multiplication, because that's what the product does within the sum product. It does the product of each arrays and sums up the resulting multiplication of each values within those arrays. So it does the same. We enter that and we obtain the results that we wanted to have. The same. So if we again select the different arguments that we have, which are in that case arrays, and we hit F9, we are going to see exactly the same as before as well for the sum function. We have an array which is separated with semicolon, and we have an opening curly bracket and closing curly bracket for representing the array. So we can also create an array by ourselves. So to create an array by ourselves, we would type also the equal sign to start a formula. Then we open the curly bracket, we place our value inside, let's say 1, 2, 3, and close the curly bracket. Now we have an array of constants, and when I hit enter, Excel is going to spill that array within our Excel spreadsheet. So note that now we have one value for each column represented in a row, because I used as a separator the comma. The comma is the representation of the separator for each column. The semicolon is the separator for each row. So we could also create a matrix and have 1, 2, 3, then semicolon, and then we have 4, 5, and 6. Here we have a two-dimension array. So we have on the first row 1, 2, 3, 1 in the first column of the first row, then 2 in the second column of the first row, 3 in the third column of the first row. We have the row separator here, the semicolon, which indicates to Excel that it has to start to a new row. Then the fourth will appear on the second row, first column, fifth on the second row, second column, and sixth will be on the second row, third column. Hit enter. Oh, sorry, I need to get out of the zoom. I hit enter, and now we have the resulting. So this happens only within the modern version of Excel. If you have Excel 27, 2010, 2013, and so on, which is not 365 and not the latest version, you wouldn't be able to have this result. Most probably what you would have, you would just see 1 here. For me, it would be difficult to represent that because in modern version, so it just spill over to the adjacent cells. But what you would need to do, if you have an older version of Excel, you would need to use the famous CSE, the Control Shift Enter on your keyboard, and you would obtain something very similar. But to obtain the same, you would need to select first. First, you will need to select all the different cells to which you want to apply that Control Shift Enter function. So let's do something. I'm going to copy that here. Okay, I didn't get that. Okay, all right, Control C and Control V. You see what happened? I obtained only 1 actually within as the result because that function, and we can see it's very particular in a previous version of Excel. You need to use Control Shift Enter to force that function to return values on each rows and columns as we have specified. And Excel enters well, virtual curly brackets at the beginning and at the end of that formula. And actually, if you click inside, Excel remove them. So that's why I say virtual, because you don't need to place them yourself. That's very important. If we were to place them ourselves manually, it will not work. Okay, now we don't obtain anything. It's not even a formula anymore. It's like just text. Okay, so those are virtual, placed by Excel whenever we use Control Shift Enter, CSE, Control Shift Enter, and now Excel returns an array. Okay, and because we have selected only 1 cell within our spreadsheet, Excel return only the first item within that matrix. Currently we have a matrix because we have two rows and multiple columns. Okay, so we have a two-dimensional array within that. And if I wanted to return the entire array or matrix that we have, we need to select three columns, well, three columns and two rows. So 1, 2, 3, two rows. I hit F2 to go in edit mode within that cell, Control Shift Enter, and now I have all the different values for that formula. Okay, Control Shift Enter formula. Now, if I were to edit that, okay, it works. Here, in that case, okay, we can edit them. Okay, you see we have a warning message. We cannot change one formula, one cell that belongs to an array formula, and for which, okay, all those cells belong together in a way. I cannot just change this and try to edit it. I cannot do that. I really need to select all the different cells that have that specific function, that specific formula, Control Shift Enter formula, to start editing it. Okay, I wouldn't be able otherwise. It's the same also for the spill array. So let's see, okay, what did we have before? Let's construct it again. So to construct a formula array of constant, in that case, I open the equal sign, open the square, the curly bracket, I place my values inside, then separated by a comma, then separated by a semicolon, and then the following values inside, and I close with the curly bracket. Enter. Because I am in a recent modern version of Excel, Excel is going to spill over the rows and columns the values of that matrix, of that multidimensional array. Okay, and I cannot edit any other of those values without breaking that array. Okay, so now if I enter some value beside in M98, it's gonna break that array, and we have the error message, which is new in the newest version of Excel, which indicates, okay, we have a spill error. So that formula cannot spill over the adjacent cells to return the right value because we have some text inside. As soon as I remove it, Excel can spill over the columns and rows to enter those values inside. Okay, so we have demonstrated functions that use arrays as arguments within that functions, and we have, okay, we can use arrays with the sum function. We can use eventually arrays also with the sum product function, and we can see that the sum product function takes in arrays as arguments, so a list of cells, or a list of cells. Okay, and we have seen also some formulas that are going to return arrays as a result. I think if you are in a previous version of Excel also, you wouldn't be able to do that, if I'm not mistaken. I think you would need to force it with the Control Shift Enter also to return the value. So if it doesn't work for you in your version, you might want to try with Control Shift Enter to force that result to compute. So arrays are represented within curly brackets and separated by comma to represent values on the same rows, and semicolons if you want to represent values listed in a column. Okay, so now how are we going to create nested functions? Well, we have, for instance, the total here for each sales, and we have a state. What if we wanted to obtain the sales for a certain state? Let's see, we could use most probably a sum if function. So we are going to create it here, equal, so equal sum if, and we are going to use that range. Okay, the state, okay, the table 1 state. The criteria is gonna be Texas, and the sum, the range to sum is gonna be the total. And we obtain 52, let's format it correctly, 52,386. We can also confirm, apply some filter in our table. We are going to look for Texas. We select Texas, okay, and now we see that the total for Texas is actually 52,386, which is correct. Okay, so that's very fine. Now, what if we wanted to obtain for more than one? Let's clear that. So we could use the sum if with a s at the end, right? So we are going to see different ways of doing that. Okay, so we can use sum ifs, so to obtain the total for different states, not just one. So we are going to select the range to sum, which is this one, then the criteria 1 range is going to be okay, the state, and what we want is Texas, and the second criteria, it's going to be again the state and California. Okay, so we do California. That doesn't work because it's like and logical or logical and. So we need to do it differently than that, and that's where, okay, we can use another way to do that. So let's delete that. Let's use a sum product. So let's see first of all that we obtain the result for California. Equal sum if we want to obtain the sum for which the state is going to be equal to California. I forgot the range to sum as well. Which is, okay, table 1, open the square bracket, and then the total. Okay. All right, so we have it. Now we can also quickly confirm that we have the right value. California. Okay, and now 40,829. That's correct. Let's remove our filter, and so we are going to format them both like this, and the total, we know it's 93,000. Let's see if we can obtain it differently as well, using the sum product, in which we are going to well, we need to sum that and we are going to use the state should be equal to Texas. Okay. What we are going to obtain with that is a true false values. So let's see, F9, we obtain an array of true and false, true, true, false. So the first two are Texas, true, true, and then we have false and false. Okay, so we need to transform that into a number, so we use the function n, we close, and we obtain the same 52,385. Now we want to include California as well. So we want to obtain California as well. So we are going to, well, we can use the same. Okay. Okay, all right. Okay, now we obtain 93,215. So we have, okay, we could use actually we are adding the results of the first evaluation, which compares Texas to each state and return true false. With the n function, it's going to change the true and false with 1 and 0. Okay, so we have 1 and 0. 1, 1 representing true, and 0, 0 representing a non-Texas state. Now, with the other one, we have the contrary. With this one, we have, so let me go back to this and select the second one and hit F9 and we zoom in it. Now we have the contrary. We have here each value for which the state is California. So the first two are not California, and then we have California, California. The sum is going to add them up. So wherever we have 0, but we have a Texas as 1, then it will be 1 plus 0 equal 1. And then 1 plus 0 on the other side equal 1. 0 and 0 equals 0, and so on and so on. In that case, it's not possible to have 1 plus 1 because it's either Texas or either California, and it cannot be both Texas and California. So if I escape that, now I select both the results of all states being Texas and all state being California. Let's do something. Let's put everything on one row so that we see a bit better. And now we transform this into an array and this into an array as well. And now we zoom in. Now we can see that for each evaluation, we have all the states that are equivalent to Texas as 1 and all those that are equivalent as California as 1 as well. Now those two arrays are going to be added up together, so they are going to be summed up together, and 1 again 1 plus 0, so 1 Texas plus 0 none being California will result into 1 1, then 1 1, and then 0 0 0 1 1 1, and so on and so on. Okay, so now if we select both formulas and hit F9, we have our resulting array. So 1 1 1 1 0 0 0 and so on, and this will be multiplied by what we have, knowing that multiplication by 0 will return 0, and then the result being summed up, we have only the sum of those states for which Texas returned true and California returns true as well. Now, instead of using a plus, we could use a sum as well. Well, this will not work because it would sum up both together, so we don't use the sum in that case, because we need to return an array. It should be an array, okay, and not a scalar value, so we cannot use the sum in that case. Okay, so we have an embedded formula within our sum product function. Now for our second data set, we have a list of books, and we want, let's say, to count how many have been read and how many have not been read. So in that case, we could use the count function. And let's see, count if this, the criteria being yes, has been read. We have 6 books that have been read. We could do using an array. We could do the same as well. We are going to select the column red and evaluate it to yes. And now if we type enter, be careful in that case, we are going to return a list, an array of false and true. Now again, I can use, sorry, I'm not in the right one, it should be this one. So here I can use again the n function to force the result of Boolean false and true into binary value 0 and 1, and I can count all those 1 as well. So now I can count the result. And we have sorry, we should sum the result actually to obtain the right information. 6. Okay, so we have embedded function because we are using the n function within the sum function. So that's an embedded function. Each time we have a function or an evaluation, a formula within a function, then we have embedded functions. And if we go back to our list of cities, we could evaluate also how many cities are being Texas. So we have our table 1, and we open the square bracket and we choose the state, close the square bracket, and we evaluate it against Texas, close the quotation mark. We have, well, it spills because it has some values below here, so if I put them a little bit aside, it will work. Okay, we have a resulting array of true and false. Again, if I want to obtain binary values instead, I'm going to use the n function and validate that. I obtain 1 and 0, and I can sum up all that. Okay. Now let's try and see something else. What we are going to do, we are going to use the OR function, and we say, so table 1 square bracket state, closing the square bracket, being equal to California, okay, and close the bracket. What do we obtain? Okay. Now this doesn't work. It returns only true, even though what we have inside are arrays. But in that function, it doesn't take an array as an argument. Okay, that's why you can see also within the sum product, the sum product specify that the argument should be an array. Where do we have it here? The argument within that sum product function should be an array. And now in the modern Excel, the sum function can take in an array of value and return an array, can compute those arrays together. And the OR function cannot do that. The OR function cannot evaluate two arrays together and return an array of that. Okay, so it has to return a scalar value, that OR function. So if you want to evaluate both, we need to use the plus to add both arrays together, each value of each array, return an array, and in that case we have an error. What did I forget? Okay. Oh yeah, because again, okay, we have true and false, they cannot be added together, so we need to embed each evaluation within the n function, so to obtain binary values and return what we want. Okay, so now we have it. Yeah, exactly. And does that work now with that? I'm not so sure. We'll see. If you obtain, no, we still don't obtain the right information as we want. So in that case, we need to keep it with the n function and addition of both. Okay. Yeah, sure. Okay, so that's about manipulating arrays and returning arrays, and how to reveal what's behind a function with arrays. Okay, so for instance, selecting a part of that function we can hit F9 and reveal the array which leaves behind. Okay, so now that's about manipulating arrays. So now let's do a little bit more with nested functions. What example are we going to take? Okay, let's see if we have some other interesting things here. Okay, so we can do quantity 38. Let's see if we have another interesting data set we can use. Let's do people and obtain some information. Okay. Okay, I don't see much interesting values here to use. So we have information whether it is paid or not paid and how much was sold. So let's say we can start identifying what has been sold. So, oh, that's the sale, the date. Okay, that's the date it was sold and not paid. So 2610. So it's almost a month. Okay, let's see if we can evaluate 1 month not paid. Okay, so we are going to or let's say 15 days, within 15 days, and they have not been paid. So if the value within the paid column is equal to no, here we are going to use AND to evaluate whether that value is paid. So let's nest another function like and evaluate also the date, the date difference between 2 days should be more than 15 days. If what has been sold is older than 15 days compared to today's date and not paid, then we should pay close attention to them. Then we should really act and start getting the money. So we are going to use another embedded function with it, that which is today, the today's function, and we subtract the date it was sold and compare the result. If it is, so that result, so what we obtain of the difference between today and what has been sold, if it is greater than 15 days, then we should definitely flag that. Okay, so if that is true, then we flag it. Otherwise, okay, we can just return nothing. Okay, so all right, I don't want any value in that, not false, but an empty. So we have now flagged all the sales that are older than 15 days. Let's zoom on that. That's how we nest functions. We have an AND function nested within an if function, and we have actually a today function nested within the AND function, which is nested within the if function. And we have an evaluation against 15 as well. So we have also a formula that evaluates the result of the difference between today and the date the product was sold. And if it is greater than 15, it will return true. And if it is also equal to no, it will return true. So if both are true, then we flag it. Otherwise, we don't need to flag it. So we have the today function. Sorry, the today function within the AND function, which all live within the if function. So here we have nested functions together, and we have an evaluation within that if function. So we have an evaluation. So today minus sold minus the date it was sold. If it is greater than 15, it should return true. And again, we can evaluate also the today's date will return when we hit F9, it return a number value minus the date it was sold. We calculate both. It returns 23. 23 is greater than 15. Yes, it is true. Then on the other side, we have the evaluation of the whether it was paid or not, which is compared to no, and it is true. And the result of both true returns true as well. So what will be the resulting value for that will be flag. Okay, so now we have nested several functions together. Okay, I think we have reached the time for this specific meetup in which we have seen arrays and nested functions. We can do a lot of things with the arrays that we have within Excel. So arrays can be represented as a row separated with comma and embedded within curly brackets. So an array is represented within curly bracket, separated by commas if it is represented all values within one row. And if we have values within a column, it will be separated by a semicolon. And now we have also used several arrays to obtain different results. Some function takes in arrays, like the sum product function take in arrays, and we have functions that are going to result as an array as well. In previous version of Excel, you need to use Ctrl-Shift-Enter on your keyboard to return all the values of that array in the selected cells, and you need to make sure that you're going to select all the different cells that well, of the size of your array. Okay, if your array has 5 values, make sure that you select 5 cells and make sure that you select them corresponding to the size of your array or the dimension of your array, whether it is on rows or columns. And we have seen different ways of computing the total using sum function with 2 arrays within it, and using the sum product as well. and we have seen how we can nest several functions within one function to obtain the desired result. For instance, all those that have a sell date older than 15 days compared to today's date, and for which it has not been paid as well. Okay, so if you have any question, please let me know in the comment, well, in YouTube. Otherwise, you can contact me as well in the meetup group, and let me know if you have any specific um, request for next meetup, if you want to see something specific, how to construct functions, how to create a table, how to use named ranges or conditional formatting, anything that you wish to know. We could also have a look at importing data with Power Query, creating data model, using different functions in Power Query to manipulate the data and obtain something useful from the extracted data. All right, thank you very much for watching. I wish you a very nice weekend and well, a very nice evening and a very nice rest of the week for now. Thanks very much and see you next time.